Welcome, my friends! Today we will be discussing logarithms, often abbreviated logs for short. Consider this expression. The way we read this is log base 5 of 25. We call the little subscript of 5 the base of the log, and we call the 25 out front the argument of the log. Sometimes you will see the argument in parentheses like this, especially if the argument is more complicated. So what does this mean anyways? Well, as you will learn as you spend more time with logarithms, logs are related to exponentials. Logs are technically the inverse of exponentials, meaning the argument, the 25 in this case, is actually the result you get when the base, 5 in this example, is raised to some unknown power. Here's how I think about it. Log base 5 of 25 asks us, 5 raised to what power is equal to 25? Think about that. 5 raised to what power equals 25? Well, 5 raised to the second power is equal to 25. That means the log base 5 of 25 is equal to 2. Now, hopefully you're starting to see what logs do. The answer to a log is an exponent. Log base 5 of 25 is asking the same thing that 5 to the x equals 25 is asking. 5 to what exponent results in 25? Alright, let's try a few more. We have log base 8 of 1. This is asking, 8 raised to what power is equal to 1? Think about that for a moment. What power could we raise 8 to for the result to be 1? Well, 8 to the 0 power is equal to 1, and therefore log base 8 of 1 must be equal to 0. How about log base 4 of 4? This asks us, 4 raised to what power is equal to 4? Hopefully you're starting to get a hang of it. 4 raised to the first power is equal to 4, and therefore log base 4 of 4 is equal to 1. How about log base 3 of 1/9? This asks us, 3 raised to what power is equal to 1/9? This one might seem tricky at first, but it really isn't too bad once you realize how to do it. Remember that when we raise numbers to negative powers, that's the same thing as raising the same number to a positive power in the denominator. For example, 2 to the negative second power is the same thing as 1 over 2 squared, or 1/4. Can you use that idea to figure out what log base 3 of 1/9 is? So again, this is asking 3 raised to what power is equal to 1/9? Well, we know that 3 squared is equal to 9, but we don't want 9, we want 1/9. So that means we want the 9 in the denominator. That means we don't need positive 2, we need negative 2, as 3 to the negative second power is equal to 1 over 3 squared, which is 1/9. Therefore, the answer is the negative second power. Therefore, log base 3 of 1/9 is equal to negative 2. Alright, how about log base 3 of negative 9? This asks us, 3 raised to what power is equal to negative 9? What do you think about this one? Well, 3 raised to any power will always be positive. There's no number 3 can be raised to so that we get negative 9. Therefore, there's no solution to log base 3 of negative 9. Or we might even say that this expression is simply not defined for the value negative 9. Generally, as we typically only consider positive bases for logs, the argument must always be positive. So the number out in front of the log should always be greater than 0 for any log in order for a solution to exist. Since logs are related to exponentials, every logarithmic equation can be rewritten as an exponential equation, and vice versa. For example, consider log base 4 of 64 is equal to 3. Could you rewrite this equation in exponential form? What I mean by exponential form is something raised to some power is equal to something. Would you be able to fill in the blanks? Well, as we've been saying, the base of a log is also the base of the exponential. So that means 4 must go here. We need to raise 4 to some power. Well, remember that the answer, or the result of a log, is an exponent. So the answer, 3, must be the exponent. The argument of the log is the answer to the exponential, which is 64. So we have 4 to the third power is equal to 64, which is our answer. Now hopefully you are able to follow along, but if you are struggling with rewriting logs as exponentials, all you need to remember is left, right, and center. Left, right, and center? Has Luke lost his mind? What could he possibly be talking about? Well, in any log equation, there are 3 numbers: the base, the argument, and the answer. In our example, we had log base 4 of 64 is equal to 3. There are 3 numbers: the number on the left, which is the base of 4, the number on the right, which is the answer of 3, and the center number, which is the argument of 64. So our exponential form is just left, right, and center, like this. Or left to the right is equal to center, if you want to be particular. If you want to rewrite a log in exponential form, all you need to remember is left, right, and center. So let's do it. Left is 4, so we write 4 here. Right is 3, so then we raise 4 to the third power. The center number is 64, so that's our answer. Left, right, and center. Done. That's all you need. Let's try another one. We have log base 8 of 1 over 64 is equal to negative 2, which we would like to rewrite in exponential form, as blank to the blank equals blank. How do we do that? No problem. Left, right, and center. Left is 8, right is negative 2, so we raise 8 to the negative second power, and center is 1 over 64, which is our answer. Done. The exponential form is 8 to the negative second power is equal to 1 over 64. You can use the exact same process to go from exponential to logarithmic form. Say you have 5 to the third power is equal to 125, which we would like to rewrite in logarithmic form. Well, logarithmic form is log base blank of argument blank is equal to blank. So what are the blanks? Left, right, and center. Duh. The base is the left number, which is 5. The argument is the right number, which is 125. And the answer is the center number, which is 3. Done. 5 to the third equals 125 is the same thing as log base 5 of 125 is equal to 3. Now you have to be a little careful if the exponential is written slightly differently. For example, take 1/8 is equal to 2 to the negative third. If you have this, you should rewrite the equation so that it is in the order that we've been discussing, which is 2 to the negative third is equal to 1/8. We want to rewrite this as log base blank of blank equals blank. Left, right, and center is all you need. The left number is 2, so the base is 2. The right number is 1/8, so we have 1/8. And the center number is negative 3, so we have negative 3 as the answer. 2 to the negative third is equal to 1/8 is the same thing as log base 2 of 1/8 is equal to negative 3. Now, we've been discussing problems with all different kinds of bases for logs in this video. It turns out there are 2 really common log bases that are so frequent we actually have a different way of writing them. The first is log base 10. Log base 10 is so common that we literally call it the common log. It's so common that if you have log base 10, we typically don't even write the base. So that means if you see something like log base b without a base written, where b is just some constant, that means you can assume that the base is 10. The preferred way of writing a log with a base 10 is not to write the base at all, meaning the base 10 is just implied. Okay, the other one is log with a base of e, which we call the natural log. You may or may not be familiar with e. E is called Euler's number, and it's kind of like pi. It's a repeating decimal that's important in a lot of math problems. It has a value of approximately 2.72, and it turns out to be useful as the base of a log in many situations. Most calculators will have a key for e. We have a special way of writing a log with a base e, which is admittedly slightly strange. Instead of writing log base e of some number b, we write ln of b. So log base e of b is the same thing as ln of b. We call a log with a base of e the natural log. So ln stands for natural log. Don't ask me why it's not nl. I'm not the one who makes this stuff up. So you will never see a log written with a base e like I have on the left. The preferred way of writing a log with a base e is just to use the ln notation. Alright, let's look at a few examples. Say we have log of 1000 is equal to 3. Could you write this in exponential form? Well, this is the same thing as log base 10 of 1000 is equal to 3. If you don't see a base written on log, that means you can assume we have the common log with a base of 10. The exponential form is blank to the blank is equal to blank. So we used left, right, and center to fill in the blanks. 10 to the third is equal to 1000. We can rewrite this without the parentheses, as they are unnecessary. Alright, how about 10 to the negative second is equal to 1 over 100, which we would like to rewrite in a logarithmic form. We have log base blank of blank is equal to blank. We use left, right, and center to fill in the blanks. Log base 10 of 1 over 100 is equal to negative 2. But log base 10 is the common log, so we don't need to write the base of 10. We can just write log of 1 over 100 is equal to negative 2. How about ln of x is equal to 2, which we don't want to solve for x, we just want to rewrite in exponential form. Well, we can rewrite this as log base e of x is equal to 2, as we know that the natural log has a base of e. Using left, right, and center, we have the left value of e raised to the right value of 2 is equal to the center value of x. Altogether, we have e squared is equal to x. Alright, one last problem. Rewrite e to the y is equal to 4 in log form. We need log base blank of blank is equal to blank. Left, right, and center gives us log base e of the number on the right, which is 4, which is equal to the center value of y. But log base e is just the natural log, so we have ln of 4 is equal to y, which is our final answer. Alright my friends, that wraps up our video introducing logarithms.